Okay, so here we have one last limit, and we're checking as x approaches positive infinity what's going to be happening. And we see that this term is going to go to 0 as x goes to infinity. This term is going to go to infinity. And so really we end up with just 1 plus 0 all to the power of infinity. This will be indeterminate because it's going to be 1 to the power of infinity, and it's an exponential indeterminate form. So how do we deal with these exponential indeterminate forms? Okay, we're always going to deal with them the same way. And really, if you think back earlier in the course to what we did called logarithmic differentiation, when we had similar issues to this, we can use a logarithm effectively to bring down this exponent. Okay, and that's very much what we're going to do. So you'll have to remember one thing about logarithms and exponential functions. They are inverses of each other, and so they have one very special property. If I want to rewrite, e to the ln of y, this is the same as y. Okay, this logarithm and the exponential, they are inverses of each other. So if we remember that property, that's going to be all that we need now to evaluate this. So let's rewrite our limit using an exponential and using a logarithm. So I'm going to write everything here to the base of e. So I have e to the ln of 1 plus 1 over x to the power of x. Okay, so that's just using this property that we just talked about. Okay, I can introduce a base of e and a logarithm, and I will maintain equality. So these two limits here are still exactly equal to each other. Now, why did we do this? Well, we know from properties of logarithms that now we are able to bring down this exponent and put it in front of the logarithm. Okay, and that's going to actually completely change our indeterminate form. Okay, that's going to give us the limit as x approaches infinity, e to the power of x multiplied by ln of 1 plus 1 over x. And here I did sort of an extra bracket there. Let's clean that up a bit. This is what we end up with. Okay, and now let's just take a look at what's happening with our limit. Okay, we used to have 1 to the power of infinity, but now as x approaches infinity, we have here this term which is still going to infinity, but this whole thing right here is going to ln of 1 plus 0. It's going to just ln of 1. It's going to just 0. So we have taken our indeterminate form 1 to the power of infinity, and we have turned it into the indeterminate form 0 multiplied by infinity. Okay, but this is very much what we knew was going to happen. Okay, this was the goal all along. So remember, if we have an indeterminate form, any of the exponential indeterminate forms, you can do this same trick using logarithms to turn it into 0 times infinity. And now that we have 0 times infinity, we know based on the last example that we can always take it and switch it over to be the 0 over 0 or infinity over infinity. And then from there, we can always just use L'Hopital's rule. And so it always follows the same chain. Okay, even though we started off with an exponential indeterminate form this time, it's definitely going to be the most complicated sort of scenario, but it's going to follow the same steps as what we were doing before. Okay, so let's get back to our limit, and let's now get ready to deal with L'Hopital's rule. Okay, so let's clean that up a bit. We now have, as we said, 0 multiplied by infinity. So let's take one of them and put it artificially into the denominator, giving us 0 over 0 or infinity over infinity. So that means we have limit as x goes to infinity. Let's leave our base of e alone. Okay, and we have to choose either to put the x into the denominator or to put the logarithm in the denominator. Now, I would say as a rule of thumb, always try to put the easier function, the simpler function, into the denominator because you're likely going to be introducing a chain rule if you with whatever you put into the denominator, because it's now going to be to the exponent of -1. Okay, and we would rather do the derivative of x to the -1 instead of doing the derivative of ln of 1 plus 1 over x all to the power of -1. Okay, we do not want to have to do this derivative. We would much rather do this one instead. Okay, so now we took our 0 times infinity, we rewrote it like this, so now we should have either 0 over 0 or infinity over infinity. So just quickly check to make sure you do. This term, remember, goes to ln of 1, which is just going to go to 0. And now this one, even though it might not be obvious, it's going to be going to 1 over infinity. It's going to be going to 0 as well. So we've turned it into the indeterminate form 0 over 0 this time, and now we are ready to do L'Hopital's rule. So we can differentiate the numerator and the denominator separate from each other. So in the denominator we get -x to the -2, and in the numerator, remember the derivative of our logarithm, we have 1 over our inner function, and then I'm going to have to do a little bit of a chain rule here. I'm going to multiply by the derivative of this inner function. And that derivative is just the derivative of 1 over x, which is -x to the -2. And actually, this looks like a mess at first, okay, considering we want to do the limit as x goes to infinity. But remember, as soon as you do L'Hopital's rule, you always just clean it up before you do your limit. So cancel those out and see what you're actually dealing with. So here, if I rewrite it now, all that we actually have is our base of e to the power of 1 over 1 plus 1 over x. And now what happens there as x approaches infinity? Well, this term goes to 0, and so the whole thing just goes to e to the power of 1 over 1. It's going to go to e, and that's it. So this limit exists, this limit is convergent, this limit is equal to e. Okay, so don't forget, okay, this setup right here. All right, anytime you have these exponential indeterminate forms, you're just going to have to do a few extra steps. Okay, you're going to introduce your base of e, you're going to turn it into 0 times infinity, then you're going to do some algebra, you're going to turn it into 0 over 0 or infinity over infinity, and then you're going to do L'Hopital's rule, and hopefully at that point it works out and you should be done. Okay, so that's, guys, a very quick, brief recap of L'Hopital's rule. Hopefully that works for you.